date, human industrial development has been defined by technology. The 18th century was the steam age, the 19th and 20th centuries the age of petroleum. The 21st century has been described as the digital age. But if we're to mitigate the effects of climate change, we should think of the 21st century as the age of carbon dioxide. The Energy Safety Research Institute at Swansea University was created to tackle exactly that problem, researching new technology for clean energy generation, storage, and conversion. A key part of our research is CO2, both sequestration and utilization. In the UK, current CO2 emissions are approximately 500 million tonnes per year, but with a goal of 80% reduction by 2050. So what are the main sources of CO2? Energy generation, transportation, and industry. Energy generation can be solved, in theory, by alternative energy sources such as solar, wind, and nuclear. In the case of transportation, hydrogen and electricity will replace petroleum. But industry is a different issue. Here in Wales, industry accounts for 40% of CO2 emissions, and Tata Steel is almost half that amount. The facility behind me could either be thought of as the largest point source of CO2 emissions in the UK, or the biggest resource of carbon, the building block of so many of the products of the modern world. In ESRI, we are working on a number of major projects, one of which is reducing industrial carbon emissions, or RICE. One approach to utilization of CO2 involves chemical conversion. This research is led by Dr. Enrico Andrioli.
Carbon is very important because we make materials that are essential for us, like polymers, fertilizers, and pharmaceuticals. Today we make them from oil and gas, but we know we have to reduce our dependency. And the way we want to make them in the future is to use carbon dioxide and convert it into these very important materials.
An alternative to chemical conversion involves biological processing. Dr. Darren Oatley-Radcliffe is the project lead.
So what we've got here is a vertical tubular photobioreactor, and we use this for growing algae. So algae basically eat CO2 along with some nutrients like nitrates and phosphates, and they use those building blocks and grow them up into larger molecules. These are high-value compounds that are very useful for nutritional supplements and pigments and proteins, which can go into the health foods and the pharmaceutical sectors.
Our key industrial partner in RICE is Tata Steel UK, where we are now in the process of developing an industrial-scale demonstration site, the aim of which is to showcase the viability of our innovative technology.
Tata Steel is firmly committed to reducing carbon dioxide emissions in line with the Paris 2050 agreement. We're working closely with our partners in ESRI with the RICE project, which is industry, academia and government working together to reduce carbon dioxide emissions. Now, carbon dioxide is a natural byproduct from iron making process in the blast furnace technology, and what we aim to do is capture that carbon dioxide and use it to create value.
But what do we do with the CO2 we cannot consume? Sequestration has to be the answer. Unfortunately, traditional sequestration has problems, including small scale, leakage, and limited locations. Oddly, the solution may be found in an unusual place. Shale gas has been trapped underground for millions of years due to the impermeability of the rock. As a consequence, the only way we can access it is through hydraulic fracturing. However, traditional fracking is not only a contentious process, but it's an inefficient one because it damages the reservoir, limiting the extraction of gas. In partnership with affiliates of eCorp International, ESRI has piloted the concept of using the heavier fractions of natural gas instead of water, thus obviating the needs for water, chemicals, or waste disposal, in combination with a form of completely non-hazardous glass that allows the reservoir to be resealed after CO2 sequestration. If this method is used, for every unit of CO2 that is released in burning natural gas, or from its conversion to hydrogen, we can store 3 times as much CO2 in the shale. If the reservoir is resealed, we can trap the CO2 for millions of years. Key to this is the development of new products that are compatible with non-water fracking, as well as products for sealing in the CO2. Rob Ireson is from Glass Technology Services.
We've been working with ESRI since 2015 when Andrew came to us and asked for a solution to get natural gas out of the rock. Since then, we've helped him develop a glass-based solution to not only get the natural gas out of the rock, but also to seal the rock up. This means that CO2 can be captured and stored within the rock permanently. We've also been working with the glass industry in the UK to help decarbonise the industry and remove CO2 emissions.
Using this revolutionary process, the UK can safely extract more natural gas for hydrogen production and sequester 100 to 500 years of current industrial CO2 emissions.
Here at ESRI, our goal is not only to create new technology for a cleaner energy future, but to demonstrate and deploy that technology. Join us on the path to that future.